like to finish up talking about our first programs by going over briefly what's in the init shader routine that we really have avoided by just saying run this function that we're giving you and is read in as part of your HTML file. So let's look over it very briefly. What I advise you to do is look at the code that's in the common directory for this function and go through it, because that function includes a lot more of the error checking that you probably want to have going on to say, well, if my program doesn't compile or link, get out of here. And that's all in there. But let's just look at the highlights of what things do you need to do to create this program object we've alluded to and to read in and link your shaders. So there's three steps. There's the reading of the shaders, there's compiling of each of the shader and trying to put things all together. The other parts we've actually talked about vertex attributes and uniform and variables. That's already kind of been done. And after I finish this, then in the next couple of lectures, I'll talk about how we take our first examples in 2D, the Sierpinski gasket that's in chapter 2, and how we go and one, use recursion to generate it very nicely, and two, how do we then go to three-dimensional applications. Okay, well, let's go back to what's in the init shaders routine. That we have to really do a fifth thing after we create everything and link everything together. We also have to then link the variables in the application with variables in the shader through the vertex attribute variables and the uniform variables. Okay, so first we need this notion of a container object, and we can just think of it as a program object, which is in fact a container object, which can contain all the shaders that we're going to use. Now, in a given application, you may want to use multiple shaders. So, for example, if you're using a metal shader to shade one surface and some other kind of shader to shade another surface, then we may want to be switching shaders in the middle of the application, but using the same program object. So the program object can contain multiple shaders of each type. It can also contain other functions that the shaders call that are written in, other functions that are written in GLSL. So we start off by creating a program object, giving it any name you want. We've only used a single one, so we can create that program object. It's the current program object right now. We can switch. There's a function use program, which will allow us to switch between program objects. So we can do GL use program, program here, program 1, or program 2. But the three key things we need is to one, read in the shader and compile it, and then attach it to that shader program, essentially putting it in that container. Do the same thing with the fragment shader, and then when we've got everything we need in there, to link everything all together. Those are the key steps we're checking for errors all along the way in the init shader function. Perhaps the trickiest part is how we read the shader in, because the shaders are written in as just strings of ordinary characters, and there's some differences between JavaScript strings and null terminated strings, and there's a couple of ways that we can go about it. Sort of in principle, what you'd like to do is just get a null terminated string from somewhere. So this is the OpenGL. If you have, let's put it this way, if you have that null terminated string, you can use the function GL shader source to then say, I've named my fragment shader, here we're just calling it frag shader, and the text is in frag element dot text. Well, we can do that in a number of ways. One of the ways is that we put the shader into the HTML file and give it an identifier, which is the route we've taken in our sample program, and then use getElement by ID, the JavaScript routine, to the HTML routine to then get that string which has been pointed to by that identifier. The other thing we can do is put the shaders in a separate file, not in an HTML file, where the advantage of that is that if your shaders are going to be used for applications other than WebGL, we might use it with some version of desktop GL, the shaders should be essentially the same. We'd rather have them in a file, or if I'm going to use them in multiple applications, I don't want to have them in have to put them in the HTML file for each application. I'd rather have all of my shaders in a single directory and then just read them in by name. I'll get back to that option in a few minutes. But if we're just adding a shader, here would be a sort of the basic idea that we say we have the element vertex shader. We then do document get element, which would get it, as we said, from the HTML file, which HTML knows how to read in that particular form of script. We create a shader. We give it the parameter vertex shader. Essentially, these routines are almost identical, whether we're doing a vertex shader or fragment shader. They're both programs that are written in the same language. So we just say, well, this one's going to be a vertex shader. We get the shader source from having read it in a document get element. We then take the text part of that element, put it into shader source, compile that shader, check to make sure that's complete. That's in the code that's on the website, and then assuming that that's been successful, we attach that shader to the program object that we created. Now, this is exactly the same for a fragment shader. We change create shaders parameter to be GL fragment shader. We get the fragment shader by its ID at the beginning, and we compile it just as we do with the vertex shader, and then attach the fragment shader to the program object. So let's assume this has been successful. Now, the difficulty here is what is really going on here with trying, or what's the difficulty of trying to read it in as just a string? Well, it's the difference in strings is causing the problem, plus our desire to put the shaders into a separate file. So if you want to write a shader reader, and actually there's a second version of init shaders, init shaders 2, which does this, which reads in the shader, we can use some HTML functionality to read that shader script in. So this is fairly simple. It says give it the name of the file and read it in as an AJAX request. You can look up how that's done. But that's really not the issue. There are multiple ways to do this step of having an equivalent function get shader, where GL is the OpenGL is the WebGL context. Shader name is the file we want that to go into, and whether it's a vertex shader or a fragment shader. The issue is that some browsers are not going to let you do that under certain circumstances. This is known as a cross-origin request, which is a security issue that you worry about in things that run on the web, of whether they can read any file locally. If they can read local files of something that's located on a server someplace, then that local file has the potential of doing harmful things. So in general, cross-origin requests are forbidden by many browsers. So this can be a problem if you try and, for example, run an application that's on, say, my website, and you want to read a shader that's your shader in there. It's going to say, no, that's a cross-origin request. I'm not going to do that. Some shaders or some browsers are looser about this than others, especially if the shaders are located in the same directory or subdirectory of the directory of where the file is. Just if you get this error message out of your browser, it'll tell you that particular browser won't do it. Try it with another browser. Sometimes I've had to switch between Mozilla and Chrome in order to do that. But generally, if you put both the shader and the application, the HTML file and JavaScript file, in the same place on a server, whether it's a local server or remote server, but on the same server, this will almost always work. But you can try various options. The option of putting it inside of the HTML file will always work. Okay, and finally, I just want to say a couple of things about the precision again. We said a couple of times why we have the precision in WebGL. It comes from OpenGL ES, and unfortunately you can't leave it out even though you're guaranteed to have medium precision available in every system. If you have a need to have high precision, you can obviously test setting the precision to high precision, and if it doesn't compile the shader, then you can go back and do that. Easier is to use a directive, an ifdef, to check it. So here's the simple pass-through shader with the ifdef in it. It checks if this variable fragment shader precision high is defined. If it is, then it sets the precision to be high. If it's not, then it falls back to medium, which is guaranteed, and then the rest of the shader looks exactly the same. Okay, so that fills in the little pieces that we're missing, and now we can really focus on computer graphics. And the first thing we're going to do in the next lecture is turn back to our Sierpinski gasket, look a little bit at specifying it recursively, and then getting into three-dimensional applications.